Hello, I'm Stefan Wick.
And this is Payman Zanjani.
We're from the Windows Developer Platform team, and today we want to talk about the Desktop Bridge and how it can help your desktop software to come to the Windows Store. All the great desktop applications that you've been developing in Visual Studio, your WinForms apps, your WPF apps, your MFC apps, you can now bring them to the Windows Store with the Desktop Bridge. So this is our agenda. So we will go over the benefits of the Desktop Bridge for your software business. Next, we will talk about how does the Desktop Bridge work and how easy it is for you to get started. Then we will take a closer look at how to convert your existing app installer, and then we will look at how to further enhance your converted application with Visual Studio 2017 and the Universal Windows Platform. Last but not least, we will go over some of the new updates that are coming in the upcoming Windows 10 Creators Update. So, why Desktop Bridge? Why should you care for your software business? There are millions of great desktop applications and games out there today. You have developed them using Visual Studio, using Windows Forms, using Windows Presentation Foundation, using MFC, or using other technologies such as Visual Basic and others. Consumers love them, professionals need them, and many of them have been around for many years or even decades. But these solutions are not without challenges today. There are user experience challenges. If you're like me and you haven't done your taxes yet, how do you find the best tax desktop software out there? Once you found the right one for you, how do you find a trusted installer that installs the software on your desktop without putting down adware or putting down malware? And once you found a trusted installer, now you have to give it admin privileges to install. Then next problem is, how do you keep it up to date? How do you get the latest updates, the latest patches, and the latest features? And last but not least, when you're done with the software, how can you cleanly uninstall it without impacting your system? I'm sure many of you have experienced this in the past. You install a software from the web, and then you uninstall it, and after that, your system was never the same again as it was before. This is because it left behind some components with system-wide impact, issues known as DLL hell or WinRot. So those are some of the user experience challenges we have today. Similarly, for the software vendors, there are challenges today because you have to develop and maintain your installer technologies and your update technologies. Also, you have to take care of monetization and licensing. Those tasks come with a lot of complexity and responsibility. Now, how can the Desktop Bridge help here? Let's take a look. With the Windows 10 Anniversary Update, desktop solutions now have an easy path to the Windows Store and to the Universal Windows Platform. Your apps can gradually utilize the features of the Universal Platform without changing your existing code base, and you can leverage all your existing code investments. As a first step, you convert your installer to the modern Windows app deployment technology. With that, you automatically get clean and simple install and uninstall. You get seamless updates with differential packages. So if you have a 1 GB package, you make a few small changes. The update will only contain those deltas for your customers. And last but not least, the user can install those packages without requiring elevation. Now, once converted, you can then distribute your applications in the Windows Store. You can reach 400 million users worldwide in 242 markets. You can monetize with local payment methods. And for enterprise distribution, you can also leverage the Windows Store for Business with your converted application. Also, once you have converted your application, you are now part of the Universal Windows Platform app model, and you can utilize all the features in the Universal Windows Platform for your existing desktop applications. You can add live tiles, notifications. You can leverage the in-app purchase APIs. You can add XAML UI components to your package, and so on and so forth. So we've opened up the store for Desktop Bridge applications in September 2016, so a few months ago, and we have seen several hundreds of apps come over the bridge so far. Here's just a small sample of apps that you may know and recognize that you can get from the Windows Store today, thanks to the Desktop Bridge. So let's see, how does the Desktop Bridge work? So let's take a look at the steps over the bridge. The first step for an application to get on the Desktop Bridge is to convert your existing installer. We convert your installer, we don't convert your code. Typically, you don't need to change your code in this phase. You can keep all your existing code investments, and you get immediate benefits from doing the conversion of your installer. To do the conversion, what we do is we record all the system modifications that your current installer does, like the file writes and the registry writes, and we create a corresponding Windows app package for this. Now, once you sign this app package that comes out of the conversion process, you're ready to install this package on your Windows devices, and you're also ready to submit the package to the Windows Store. As the next step, now that you are in the Universal Windows app model, you can now access Universal Windows Platform APIs, such as LiveTiles and other APIs. So you can continue to further enhance your application in ways that were not possible before. Also, now that your package is a Universal Windows app package, you can add more components to it that are UWP features. You can add background task components, you can add app services, you can add components that contain modern XAML UI, and so on and so forth. This also now enables you to migrate your code from your desktop process over to UWP processes. For example, you could decide to replace your existing traditional UI with a modern XAML UI, but still keep your existing code investments in your backend business logic in your package because you don't want to touch it. And then as a final step, if you migrate all your code over to the UWP part of your package, now you can distribute that package to all Windows 10 devices, including HoloLens and Xbox. So let's zoom into the conversion process here a little bit. There are a number of options out there for converting your app. The default option really is our desktop app converter, and Payman will go over that in a couple of minutes and show some concrete examples on how to use it. So this is a tool, it's a command line tool provided by Microsoft, but it's not the only way to do the conversion. If you have like a simple app that doesn't really have an installer, it's just an exe or an Xcopy deployed application, you can also do the conversion straight in Visual Studio with the SDK tools that are provided. And I will show that in a second as well. And last but not least, we have a number of third-party tools available today that are providing support for the Desktop Bridge. I have listed some of them here that are available today. So if you're a customer of some of these tools, you get the support for the Desktop Bridge automatically, and you can convert your software to a Windows app package and distribute it with the Windows Store. Now let's do a quick demo for the conversion. I will switch over to my other machine here. And before we look at the code, actually we can start looking at the code to kind of get an idea of what we're trying to convert. So this is literally the Hello World .NET application, probably the most simplistic .NET application you can write. and I want to take this application and manually convert it to a Windows app package and get it ready to install and distribute via the Windows Store. Before we do this, I need to do a little bit of homework here for you, and I want to show the typical layout for a UWP application. So for a Windows app package that contains a regular UWP application, the typical layout looks like this. So you have at the heart and center of a package is your AppX manifest. This is an XML file that describes all the content of your package, how it's laid out in the installation folder, what all the different pieces mean, and how the components are activated and interact with each other. Also, of course, we have our application code in the binary here, so we have exe files and DLL files. We may have some additional content here, text files, image files, and so on and so forth, and those can also be in subfolders, of course. And then, last but not least, we have our visual assets for things like tiles and splash screens and things like that. So this is a typical layout that you may be familiar with if you have done UWP development before. Now, for a desktop bridge application, I have an example here, and you will see it looks pretty much exactly the same. So all the pieces from the UWP Windows app package are here as well, with two notable additions. So I have the VFS folder here. So VFS stands for Virtual File System. So this is a folder in your install directory where we put all the files that your current installer would write outside of the install directory today. So for example, if your current installer writes something under Windows, you will find it here under VFS. Or if it writes something to the common app data folder, it will be redirected here as well. So this way we ensure everything is localized to the app's install folder, and we can cleanly uninstall it if the user chooses to uninstall your application. Similar, we have this registry.dat file. So this contains all the registry writes that your current installer does to the system, and localizes it to a local registry hive. So we don't put it in the global registry. It's localized here, and we can cleanly uninstall it without leaving any system impact behind. Now at runtime, when your application runs and it tries to load a file from, let's say, the Windows folder where it thought it put it down, the platform is smart enough to then redirect that request and load the file from the install folder. So your app code doesn't need to change. It doesn't need to know anything about what's happening behind the scene. The platform will do the right thing for you. Same for the registry as well. Okay, so that was the homework part. So let's switch back here to Visual Studio, to my Hello World application. And so I want to add one line here to kind of show that my app, once converted, is actually running in the UWP context. So I will add a UWP API call here. And so what I want to do is get the name of my package identity. So every UWP application has a package identity, and the app can query for that name. So now if I just hit F5 here, try to run my Hello World app with one line edit, I will expect an error. And here is the error. As you can see, the process has no package identity. That's the expected error that you would get from a regular desktop application, trying to use this UWP API. Okay, so let's do the conversion. So let me grab my binary here from the output folder. And so here we are. And so I will drop this in this folder. And so this is my minimalistic Windows app package layout. I have my exe, I have my manifest, and I have like a few assets here for my app list tile and my start menu tile. So let's take a quick peek at the AppX manifest. If you're familiar with UWP development, you may have seen this before. The structure is exactly the same for desktop bridge applications with like 2 or 3 notable exceptions. So I'm pointing my application object to my desktop application exe, and I specify as entry point windows.fulltrust application. So this tells the system this is a converted desktop application. It needs to be launched like a desktop application. And I also need to declare a capability that this application needs to run in the same kind of context as it used to run, so it still can do all the same things that it used to do prior to the conversion. Also, you may notice that I'm targeting Windows.desktop here. This application can only run on desktop. It cannot run on other SKUs of Windows, such as HoloLens, because I have not completed the migration. So this is my manifest. Now let's see how to convert it. Let me open a Visual Studio command prompt here and navigate to this folder. And so I have prepared the command line tools here. So you don't need to remember the exact command lines because typically you will do this using Visual Studio. But I want to do it like manually on the command line so you guys can really see there's no magic here, and it's all pretty straightforward and easy to understand. So as a first step, I run the make appx command, and I'll point it to my package layout folder. So this will produce my Windows app package. And so now this has been created. Here we are. And this package now on Windows, I can already double click it because the OS comes with an app installer for Windows app packages. So you don't need to author an installer. You don't need to worry about that. Windows provides that for you, and the user can go ahead and click install. Now, in this case, I get an expected error here, and it tells me, hey, this package isn't signed with a trusted certificate. So this is very important. Windows will only install applications that are signed with a trusted certificate, either coming from the Windows Store or any other trusted certificates that you might be using within your organization. Okay, no problem. I can fix that. I can sign my application with my trusted certificate. Again, with an SDK tool that comes available, with the Windows SDK and with Visual Studio. So now I've signed it. Let me try it again. Double click here, hit install. Now it actually installs. I can launch my application, and now you can see my Hello World application succeeds, and it prints out the name of my package identity. Okay, also my app now shows up here in my app list, and I can go ahead and uninstall it cleanly from here again. So now with this package, I'm also ready to submit it to the Windows Store and distribute it to the world. I've already done this and submitted it to the store. So here it is. I can open the Windows Store client application. Here's my app. I can hit install. It'll download from the Windows Store, install it, and here we go. Now I can launch it. Here's my app running directly installed from the store, and here I can go uninstall it again. Okay, so that's my demo for Hello World, and we will see a couple more complex conversions in just a minute. So let me go back to my slide deck here. And before we look into more complex conversions, I want to call out a couple of things for you to know. I mentioned already that you can bring any application type to the conversion process, whether it's WinForms or MFC or even a VB6 or Electron app. However, there are a couple of guidelines, rules, guidances that we have out there that we want apps to follow as they go through the conversion and come to the Windows Store. This is to ensure the best possible user experience and user confidence in apps they acquire from the store. And so here are a couple that I want to call out as part of your preparation for conversion. You want to make sure you test your app on .NET 4.6.1 to make sure it works with the version of .NET that is in the box on Windows 10 Anniversary Update. You don't want to require it to run with elevated privileges. The user can install your app from the store without requiring elevated privileges, so they should be able to run it without extra privileges as well. Don't install kernel mode driver or NT services with your package. Those have system-wide impact, and we can't guarantee a per user clean install, uninstall for those type of components. Don't use the local app data for communication with other apps, because you've seen the local app data is being redirected. So you should not make assumptions about other apps knowing where your local app data might be located on the system. And also don't write to the install directory. The install directory is locked by the system. We will not allow you to write you there. If you're currently doing this in your existing application, you would have to change your logic for that. This is also to ensure we can seamlessly update your application and cleanly uninstall it. So now we'll move on and do a couple more conversion demos that are a little more complex and interesting than my little Hello World. And for that, I'll hand over to Payman.
Take care of that. Thanks, Stefan. So I'm going to be using the desktop app converter for these conversions. There are a couple of things I need to do first. First thing, I need to download the desktop app converter from the store. I can either go to the store application and search for desktop app converter, or I can go to akms/converter and get it from there. So once I download that, the other thing—
You want to put your slides to the background so folks can see your store.
Oh, let me fix that. There we go. Better, okay. So I've already done that. I've downloaded the desktop app converter on my machine. The other thing I need to do before I can do my conversion is I need to go and download a base image for desktop app converter. This is what desktop app converter will use to get a diff of all the changes that our installer added to the system and create a package from that. So what I'll need to do is I need to download the base image that matches the image that I'm running right now. On this machine, I'm running 15048 from the Insider previews. So once I download that, I need to expand that package, base image. So the instructions are on the Dev Center link that I just opened. There are two things you need to do. One, you need to set your execution policy to bypass, and then you will just use this command and pass the WIM file that you just downloaded to the desktop app converter, which will then expand that package for you. Now, this does take some time. It does require reboot too. So I've already gone ahead and done that so we don't waste time on this demo. So after you do these two things, then you're ready to do your conversion. I have two examples I want to show you. The first one is Open LiveWriter. And you'll see that what I'm doing here is I'm adding an installer argument. By the way, all these arguments are documented on the Dev Center page that I just showed, so you don't need to really remember that. But what I'm doing here is I'm passing the installer as an installer argument. Now, because I'm using a setup.exe, I also need to pass in an installer argument. This is the argument that you would use to do the install unattended. Note that for using Desktop App Converter currently, you do need to have an installer that supports silent installs or unattended installs. So after that, I'm adding my publisher name, my version number. This make Apex argument is going to create a packaged app for me. If I don't pass this argument, then I'll need to do what Stefan showed with running the make Apex myself. A couple other things I want to call out here is my app executable argument. This is to help the DAC, or Desktop App Converter, find which binary should be the main entry point. Now, a lot of times you don't need this argument, but I'm just adding it here to show that this is one of the supported arguments. As well as using my install, I should have wrapped this, my install path, so DAC knows where to find this Let me see if I can wrap this so you guys can.
So that's quite a command line there. Yep. So how often do people totally need to run this?
They don't. You usually just need to run this once. Once you do that, then you do have a packaged app, and from there on, you can just do your regular deployment. So yeah, just as I said, I wanted to show you the whole script that I have here. And then the dash sign at the end is going to show the signing that Stefan did manual as well. So let's go ahead and run that and see what we get. You'll see that DAC is doing some pre-checks, make sure we have the right image. Then it's going to create an Apex or a manifest for me. It's going to try to find all the assets and whatnot. And here what it's doing is it's running the installer in an isolated environment so that it can grab all the changes that we're adding to the system and create a package from that. So once it does that, it will look for all the entries that we've done in the file system folders. This includes folders in program files, in local app data and such. And you will see at the end it's creating the package for me, and it's going to sign it, and there we go, it was successful. So it's going to point us to the package, to the path that it created for us. So I'm just going to go there, and you'll see my Open LiveWriter folder over there.
So that's pretty cool. So you had an installer that was probably created years ago, didn't know anything about the new Windows app package and the deployment technology, and a minute later you're there, have a new package, and you're ready to utilize the new modern deployment technology.
Exactly. And just to go over some of the things you'll find in this folder, this is my packaged app, obviously. These are the certificate that it used to sign that app. And then you have the logs, and you also have the packaged files here, too. So if I wanted to make any changes, I can do it right here. A lot of these, Stefan already went over. We do have an assets folder. This is where we find all our binaries for the app itself. And we do have this VFS folder where we've captured all the changes that this installer made outside the installation path. And then we have our manifest, we have our resource files. One thing I wanted to point out is Open LiveWriter is using an update.exe to do for their update mechanism. Now, once I submit this to the store, I do not need that update.exe binary because store will take care of updating for me. So what I should or could do is I can just go ahead and delete this binary and just create a new package from this payload over there, because that's a binary that they don't need. And a developer that does this will get a chance to pick and choose or remove binaries that they feel like they don't need.
So that would be kind of a typical change developers would need to do as part of the conversion, whatever update mechanisms they have. It's no longer needed in their packaged version of their app, and they can just delete that code or delete those binaries.
Correct. So let's go ahead and install this package. What I need to do first is I need to install the certificate that DAC created for us. I'll need to add it to the trusted people over here. And
so this is for testing purposes?
Exactly. Once this goes to the store, you do not need to do that. Store will take care of the certificate for you, and it's already trusted. So now that I've installed it, I can just go ahead and click on it, click install. And I should be able to get a launch button here. where
Wow.
I get the configuration page, which is the first Ubi experience of Open Writer.
That's awesome.
Yeah, very simple. I mean, a lot of folks don't realize how easy it is, so I just picked this example to show how that goes. So I have a second example I want to show you. Stefan already showed it, which was the Photo Store app. This is a simple app where we have an MSI for, and I'm just going to quickly install it. Notice I get a UAC prompt with MSI, so none of that anymore once we convert it. And then to show you what this app does, didn't get it. There we go, Photo Store. It's just a simple app where we have a bunch of prints over here that we can order. You know, we can change it in any way we want.
What technology did you use to write it?
This is WPF app. So it's just a simple app. You know, we can just add to cart and just, you know, order some of these prints. So let me show you how I can convert this one. Now remember, we had an MSI for this one. So I'm going to be using slightly different string to convert this. First of all, because it was an MSI, we do not need a silent flag for it. DAC is smart enough that it will find the right flag and pass it there. And also notice that I'm not adding any other arguments as far as, you know, the install path or the executable, because it's a simple app with few binaries. So let me run this one. Again, you'll see the same things. It's doing the pre-checks, make sure we have the right image, create the manifest for us, and then it will run this installer inside an isolated environment. And if I can show it there for you, it actually picks up the right flag for it when it's doing the installation. Once the install finishes, it's going to capture the diff between the package and the base image, and we should be able to get a package. There we go. So installation did get an error.
Okay, so this
Yeah,
is live.
maybe.
What was the error?
I think I had the file open, so I couldn't
okay.
probably do it. Let's try that again. Hopefully it works this time.
Yeah, and again, you know, this is a conversion you're doing without, you know, having to change your code. You know, you have your existing WPF code that you wrote several years ago, and the installer that's been around for a while. You throw it into the converter, and out it spits your Windows app package for your existing code. And that existing code, you can still, you know, use the same binary and deploy it on Windows 7. But now you have it also in the Windows app package and can take advantage of the universal Windows platform.
Yeah, I'm hitting that access denied error again. I'll have to look into see what's going on. But I've already done this conversion, and let me just show you what I would get. Sorry, wrong folder. There we go. So I've already done this in the past. Same thing you would see. I do get an Apex here with my cert files. And my packaged files are here. You'll see I have my regular assets that DAC was able to extract from the package. I have my VFS folder, my manifest, my registry, Hive, and my resource files. So let me go ahead and install the certificate for this guy to show you the install. Over here, we install it in Trusted People. All the instructions are on Dev Center.
So you have a lot of practice in doing that.
Yeah, did a lot. And there we go. We can install it now. And
Sweet.
I can launch it again. It looks exactly like what it was before.
And so now you could go ahead, put this into the store, distribute it to all your customers this way.
Exactly. One thing I wanted to call out is right now there's no way to support installation if you do not support conversion if you do not have an installer. But we're having in the next release of Desktop App Converter, we're going to support converting your files only without an installer. So what you would do is you would just pass the folder that you have all your files as the installer argument in your DAC, and you'll be able to convert.
Oh, so that's handy. So basically what I did manually earlier, then the
You should-
converter would do exactly for
Exactly.
that. I would just point it at my Hello World layout folder, and it would create it for me.
Correct. Okay, and with that, we can move back to the slides.
All right. Thank you, Payman. Those were awesome demos. So now that we have converted our application using Desktop App Converter or other available tools, we can actually go ahead and enhance our application further using Visual Studio 2017 and the Universal Windows Platform. So we've already mentioned with the conversion, it really brings your existing desktop app over into the Universal Windows app model. You have a package identity now. That means the system knows about your app. It knows how to activate it, how to shut it down and update it if it needs to. And just having the identity will enable a lot of UWP APIs to be available directly for your existing desktop processes. So you can call them now and utilize those functionalities. For example, all the Modern Toast and LiveTile APIs are now available directly from your desktop process. Also, you've seen you have a regular AppX manifest in your Windows app package for your desktop software. So this also means you can further extend your package and add additional components to it that are UWP components or that are desktop processes to further enhance and extend your application. For example, you can add background services that trigger on certain system conditions. You can add app services to your package to make services available on the system to other applications. You can participate in the sharing contracts. You can add XAML UI components to your package, and so on and so forth. And what else can you do? Yeah, literally you can do anything a UWP can do. So you have really the best of both worlds here in this configuration. You leverage your existing code investments that you have developed over the years, but also you have full access to all the new modern features in the Universal Windows Platform. So let's see a couple of those things in action. So we'll have two demos prepared that Payman will show you. And this will demonstrate how you can take basically the output of the conversion and use Visual Studio 2017 and the Universal Windows Platform to then further enhance your applications.
All right, so I have two examples I want to show you. The first one is the WPF app that I just showed that we have here. And what I'm going to do is I'm going to extend it to make it a share target so that users can easily share pictures from different applications such as the Photos app, or from Internet Explorer or Edge.
What is a shared target, Payman? Can you explain this?
Yeah, so I can actually show you. I have this picture right here. And what I can do is we have this handy button here that I can click on, and I get to share this content with different applications. So for example, I can click on Twitter, and I can send this picture to my Twitter feed very easily. It just makes it easy. And there are different apps that support this. And what we want to do right now is make our WPF Photo Store app be able to do this. So let me hop over to Visual Studio. You'll see I have two projects here. First one is my Photo Store app written in C#. And what I've done is I've added a second component, UWP component, called the Shared UX, where I've implemented my Share UI in XAML. Now, first piece I want to show you is the manifest. What I've done here is I've declared a share target extension to let the system know that we want to activate whenever the user chooses this certain type of file and selects our app as the share target. And you'll see that I've pointed this declaration to my Share UX that I've implemented here. Now, if I wanted to show you the UI, the share UI is just a simple UI where I have a button which is going to send it to WPF, similar to the one that you saw for Twitter, and my content, my picture will show up over here.
So I noticed you were using the package manifest editor here in Visual Studio. So that's actually pretty awesome. So this means now all the great new UWP tooling that we have in Visual Studio for UWPs, once you have converted your app, you can also just use those in your desktop application and declare extensions and manage your visual assets and all that pretty easy.
Exactly. It makes it a lot easier, so you don't have to write in the XML file yourself. You can just use the editor. And then, so what happens here is when the user selects our app as the share target, the onNavigated2 event in this component gets fired up, and we get access to our shared data. So let me just show you this app in action. I'm just going to deploy it here, and it should install it for me. There we go.
Seems like you're a C++ fan, seeing that code there.
Yeah, I do like C++, but you don't have to use C++. In fact, in the second example I'm going to show you, it's all C#. You're free to use any language you want. In this example, I'm just using C++. So this is our app, and what I can do now is I can go to my photo, click on share. I should see my WPF app as a share target here. Click on it, I will get the share UI that I created in XAML.
This is the XAML that you wrote, okay.
Exactly, and then this button is going to send it here. Let me try that again. Something's wrong with my computer. Let me try that again one more time. Just remove this guy, in case that's messing up something for me. Yeah. Okay. Let's try it again. I will deploy it. And there is my share target app. Now I can go click on share. This guy.
All right, there it is.
So now I got this content. It was really easy to do, and it's a nice feature that
that's an awesome feature to bring users into your app. They might have pictures or content elsewhere in the system, and this is a great way to advertise your app and bring them back into your app. So
exactly.
Cool.
So in the second example that I want to show you, we're exposing an app service from a WinForms application to give other applications controlled access to its database. Now, this app does not need to be running. The way we have it set up is that it's running, the app service is running in a background process, so you can have your WinForms app closed and it will still work. So let me just show you this WinForms app. I've already installed this from the store. So it's just a simple app. I have 2 entries here. And what I'm going to do now is, let's hop over to the Visual Studio. You'll see the first thing that I've done is, again, I've declared an app service extension in my manifest. I've called it the data app service. Remember this one, we're going to have to use it later. And I pointed it to this app service component written in C#, which is over here. So this is where we've implemented the app service. And let me just quickly go over some of the points here. This is where we're deferring to make sure so that the service isn't, we get a deferral so the system isn't terminated. Then we associate a cancellation handler with the background task. We then retrieve the app service connection and set up the listener for incoming requests. And once the connection is made, we get the lookup ID and we load the data from local app data. And we query the requested item and prepare for the response.
So since the service is in the same package as your WinForms application, both have access to the same local app data. And
exactly.
This is how the app service can actually service those requests even when the UI and the WinForms UI is not running at all.
Exactly. And you'll see I have a third component here. This is my test client. Technically, this is an external app. But in this example, I just included here so I can show the demo. And a couple of things I've done here is we do add the connection here. I need to pass the name for the data app service that I created, which is what I added to the manifest. We also need to pass in the package family name of the package. There are APIs you can use to get this PFN, but I knew it, so I hard-coded it in. And once we get the connection, we enable our request button, and we prepare for the data. And that was about it. So I've already installed it, like I said, from the store. Let me show you. This is the test client.
So this test client, that's a UWP app here. Does it have to be a UWP app?
No, it can be any kind of app. So I'll do the connection here. I got the connection. Now my submit button is activated, and I can look for the information that is stored in our WinForms app. I can do another query for this guy, and I'll get the same thing. And that's it. Very easy to do.
Now close the WinForms app and see if it still works.
Oh yeah, there we go. You see, I still have my connection. I can submit this. Well, I already showed that, but yeah, it's still doing that.
Cool.
All right, we can move back to the slides now.
Awesome. Yeah. So now in the last part of our training, I want to take a peek at what's next and what's new in the Windows 10 Creators Update that is upcoming. So we have a number of great enhancements and new features for the Desktop Bridge in the Creators Update. So let's take a look at some of those. So we have added a number of additional shell extensions that your app can declare as part of the conversion process. So this will enable your application to deeply integrate with the Windows shell on the desktop computer. Also, we are providing a way for your app to declare public COM objects in the package. So this will allow other apps then to use those COM objects and automate and extend your application. We also have added support for pre-install. So apps that come pre-installed with Windows images can use the Desktop Bridge and can be updated via the Windows Store. We have some great support for transitioning the user when they go from an older version of an application that was installed with an MSI or similar technology, and they upgrade to the Windows Store version of a desktop app to help them through that transition and transition some of the things like taskbar pin and start menu pins. We also allow custom font installation for apps using the Desktop Bridge and to declare firewall rules. And last but not least, we're now including WAC tests for Desktop Bridge apps with the Creators Update. So this is new. This will help you streamline some of the onboarding procedures so you can run the tests locally yourself before you go into the submission phase of your application. And we can help you catch some of the common issues there up front. So there is actually a common theme in this list of features. It's a fairly diverse and complex set of features, but they have one common theme here. And the theme for us was really to kind of close the gaps in the Desktop Bridge so that we can enable some of the most complex applications that are on desktop today and bring them to the Windows Store, including some of the biggest apps that Microsoft ships today. So, and with that, I want to close and point out a number of resources that we have available to you on this slide. We have a ton of documentation out there on AKA-MS Desktop Bridge. There's a pointer to the converter that you can get from the store with a lot of documentation also on MSDN. We have a number of samples out there on GitHub, including the 2 samples that Payman showed today. And then I also want to point out at the Microsoft Virtual Academy site. We have just finished recording several hours long material Microsoft Virtual Academy course about the Desktop Bridge that goes into a lot of detail of all the different pieces of conversion, enhancing, how to call APIs, how to add background tasks and app services, and really covers everything in a lot of detail. So this is coming in the next couple of days, around mid-March 2017. So check back for that, and hope you've enjoyed our little presentation. Thank you very much, Payman, for all the demos. They were awesome. And thank you very much for listening.